In the next part of our seminar, we're going to be looking at half-angle identities. So the sine of theta over 2 is plus or minus the square root of 1 minus cosine theta all over 2. And the plus or minus is because it depends what quadrant you're in. Cosine theta over 2 is plus or minus the square root of 1 plus cosine theta all over 2. Notice it's kind of like our power reducing, isn't it? Tangent theta is plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Or you can write it as 1 minus cosine theta over sine theta. Or sine theta over 1 plus cosine theta. And once again, here's the proof, what I'm going to skip, but it's there for you if you want to read through it. How do I use that to find the exact value of the sine of 22.5? Because 22.5 is not on your unit circle. This is what we're thinking. So theta over 2 is going to be 22.5, which means theta is 45. And we know how to find trig functions or circular functions of 45 degrees. So let's do this. So the sine of theta is plus or minus the square root of 1 minus cosine theta all over 2. However, I want to make sure I copy that down right. However, since we're dealing with 45 degrees, this is a first quadrant angle. I don't have to worry about the negative on this one, so I'm going to erase the negative. Now let's substitute in the values we know. So I'm going to say, but theta then is 45. So I'm going to say, well, I didn't write over 2 here. So I don't need the plus. I don't know. I wrote that down. So the square root of 1 minus the cosine of 45 degrees all over 2. Well, the square root of 45 degrees is square root of 2 over 2, isn't it? So it's the square root of 1 minus the square root of 2 over 2 all over 2. Ooh, a lot of 2's there, isn't there? Well, let's rewrite the numerator with a common denominator. So I'm going to say the square root of 2 minus the square root of 2 all over 2, and that's all over 2. Well, that's the same thing. 2 times 2 is 4. So you have the square root of 2 minus the square root of 2 all over 4. We can take the square root of 4. I can't do anything about the numerator. So that's going to be the square root of 2 minus the square root of 2 all over 2. Because the square root of 4 is 2. Now you can check this with a calculator. Let's find the sine of 22.5 on a calculator. We use a scientific one that's in degrees. So if I take the sine of 22.5, I get about 3.3826, don't I? Now, if I do what I said here, if I take the square root of 2 minus the square root of 2, and I should put that whole thing in parentheses, and I divide that answer by 2, notice we get the same answer. So it checks out for us, doesn't it? Whoops, I didn't mean to stop that. I just want to go back to it. Oh, we want to stop it because we're at the end of the page anyway.